We talked about this earlier in the year, I guess, when we talked about drawing different graphs and what have you. But let's just recap sketching polynomials in general. So if you have to draw y equals some polynomial, remember the y-intercept will always be the constant of the polynomial, because you'll be setting x equals 0. So all the x's are 0, you're left with the constant. So in this particular one here, now I don't have to expand the whole thing out to work out the constant. I can just multiply all the constants together. So we're going to have 1 times -1 cubed times 2 squared. Oh geez, what is that? That's negative, isn't it? -4. So we'll plot that in. There's our y-intercept. Okay. The x-intercepts are the roots, or the solutions. Now fortunately this is already factorised for me, so I can find those roots quite easily. First parenthesis gives me -1, next one gives me +1, and then the next one would give me -2. Okay. Now, this idea is about what we call dominance. So as x approaches plus or minus infinity, the polynomial will act like the leading term. And the reason for that is, I mean, obviously you can't substitute in infinity, but it's a really, really big number. So if you substitute in, theoretically, into the power of 4, that is so much bigger than power of 3. Right? Because think about it, okay, when you substitute in 1, there's no difference. Substitute in 2, then the difference between 2 cubed and 2 to the power of 4, it's already starting to get a bit bigger. 3 cubed compared to 3 to the power of 4, bang, it's getting even bigger again. 4. So now you're talking about infinity. So that's a huge difference between the two. So all those other terms are insignificant. When we're talking about infinity, that allows us to work out where our polynomial starts and finishes, because it will always act like that leading term, because it's going to dominate. Now in ours, the leading term, again, I don't have to expand the whole thing out. I can just multiply all the leading terms together. X times x cubed, so I'm up to x to the power of 4, times x squared would be x to the power of 6. Now if I'd said to you, draw y equals x to the power of 6, hopefully you would draw that U sort of shape. So we know this one must start up here on the left, just like x to the power of 6 would, and it would finish over there somewhere. So it's got to act exactly like that leading term. Okay. Now the roots themselves will always behave like the factor that we have. So if our factors to an even power, it'll just touch the x-axis in a sort of U shape. Again, the higher the power, then it'll go flatter at the base, steeper at the sides, just like our regular x to the power of whatever. Now we've got an even one over at -2. I know it's starting up here. So if it's going to come down and just touch and turn at -2, I know at -2, well, it's going to do something like that. All right, well, same thing happens with the odd powers, other than the power of 1, of course, because power of 1 would be a straight line. It's a power of 1 that just cuts it like a straight line. But it'll inflect like our cubic, if it's power of 3 or power of 5, any odd power will do that. We've got an odd power over at +1. So if I'm finishing up here and I've got to come through and inflect at 1, then I know that curve must do that sort of thing at 1. Now, we've got a y-intercept at -4. That other x-intercept, it'll cut like a straight line. There it is. That's where it is. Now, how do I know it turns on this side rather than turn over this side? Well, now we've done a little bit of a calculus, I could explain that to you, because basically I could find where the tangent is horizontal, and I could work that out. Don't worry about that too much now. I mean, we'll see more of that when we look at some more calculus later on. But as a sketch, I guess I just took a guess and went there. Now, if you can completely factorise it as a perfect square, cube, power of 4, what have you, well then we know it's just a basic curve, but it's been shifted so many units to the left or right. Well, let's try this. We'll put this one all together. Well, oh geez. Oop, there it is. Let's see where all this information comes from. The y-intercept, well, I would have gone minus 1 to the power of 4, which is 1, times 1 cubed, 1, times 2 squared, 4, times negative 2. So my y-intercept's at negative 8. Okay. The leading term, x to the power of 4, times cubed, I'm now up to 7, times squared, I've now got x to the power of 9, times another x, I'm up to x to the power of 10. So again, we're going to have that leading term would have that U shape. So we start up here on the left, finish over here on the right. Now, well, let's go with the squared first. At negative 2, it's touching and turning like a parabola, but you'll notice over at positive 1, it's still a U shape, but the power's higher, so you can see how it's a bit flatter at the base and a bit steeper at the sides there. And then we've got the inflection at negative 1 as well. And again, where they actually turn, well yes, we could use calculus to find all of those particular values if we wanted to go into it in a lot of detail. But at this stage really it's just an estimate as we're just drawing a rough sketch. Okay, there we go. That'll do us for today.